A very good afternoon to each one of you. On behalf of Bangalore Chamber of Industry and Commerce, we welcome you all for this webinar on climate resilient water management for sustainable future. Um, this webinar is the third in the ESG webinar talk series. The session is organized under the aegis of the Chamber's Environmental, Social and Corporate Governance Expert Committee, chaired by Mr. VC Mohan, Senior General Manager, Corporate Office, EHS Management India of Bosch Limited, and co-chaired by Mr. Rajesh Jha, Country Environment and Sustainability Manager at ABB India Limited. On behalf of the Chamber, we acknowledge the support of Mr. Akash Deep, Senior Program Manager and Area Convenor at GRIHA Council, TERI, and Mr. Ravitej Hegde, Chief Executive Officer, Paryaavarneer Engineers and Consultants, for accepting the Chamber's invitation to address at this session. The Chamber acknowledges the immense support of its member organization Mrs. Bueller, Brigade, Continental, Fundermax, IAMPL, MTR, Ramaya Institute of Management, SDMIMD, Sona Group of Companies, TVS Motor, and Vishwas for their immense support during the activities of the Chamber for the year. Thanks to all the participants for joining at this session. And I now hand over the stage to Mr. VC Mohan. Over to you, sir. Thank you.
And water has proved to be a very important and scarce resource all along. If you look at the civilizations, many civilizations thrived because of availability of water. And we also know that they vanished because of, after some time, because of over usage of water or, changes in the climate. The civilization vanished because of absence of water. And, we being comparatively more, intelligent after industrialization, we are putting all resources which are available in the Mother Earth for our use, and we are improving the comfort level for ourselves. And it is quite interesting journey, last 150, 200 years. And today we are, I would say on the positive side, really we are experiencing the benefits of so much development which has happened after industrialization. At the same time, we are using the resources. Having said that, it's also important that we should understand the carrying capacity of Mother Earth, and more so with respect to the availability of water, which is required for the, I would say, the complete ecosystem on the Earth, because water is the important thing, and water cycle, because of the water cycle, we have the climate across different regions, and this is getting disturbed. So before going into the details, I will request Mr. Devarajan to speak, being World Water Day today. And then Rajesh, you can introduce the speakers. We have two eminent speakers, Mr. Akash Deep and Mr. Ravitej Hegde. And then we can go forward. To the participants, thanks for joining.
Tip is to bring awareness. This is a feedback. This is how.
Yeah, so what I would say to the participants is, please use this opportunity. Let us interact. We are all, most of us from industries, and we know at the operation level the challenges in the availability of water and ensuring water security for our business. And also, it has to be integral part of our business. So over to Mr. Devarajan.
Yeah, thank you very much, Mohan and Rajesh. And on behalf of Bangalore Chamber of Commerce and Devarajan, I'd like to thank Akash Deep and Ravitej Hegde for finding out the time, both from TERI, and important us to share on a world, especially on the International Waters Day. See, as what Mohan did mention, water is a main resource for our own existence itself in many areas. And as you know today, every area, there's a lot of development is happening. Every area, whether it's infrastructure, our own movement in terms of the GDP growth, all are definitely growing in terms of the positiveness. We are among top five, will reach top three, 2030. All are fine. If you really look at, we have already signed as far as the government is concerned. We have already have the COP. We have already signed, especially on the Paris Protocol, and saying that we are going to maintain and sustain the nature, especially on sustainability. The main thing is all of us, the members in the meeting today, we should not have a business to meet all the regulations alone. If you say I'm in a business in terms of I'm meeting all my regulations of the government, I'm in business and making money, that is not enough. We need to be in business to take care of the nature. Because we find if we take care of the nature in all our activities, in whatever we are doing it in our industry, nature will take care of us. We are able to see this is a major change in our understanding of business itself in terms of the mindset is definitely needed in today's world of water in the International Water Day. The reason I'm mentioning is it is not only in the end of the line saving of water, every portion of the water in the process, in the product which we make, the way of usages, recycling, repurposing sometimes, it's every area it's important to save. If you go back to our own culture, for example, even if you take into our Vedas for area, all the tattvas, example, Agni, Vayu, space, any area, we have to go back into our culture and say we have to save all these things and make improvement. So one is water. The main reason why water is coming down in especially in Bangalore is lack of greenery and usage of all the lakes for our development. I think we need to have a crusade among ourselves to say that we are not going to encroach into the lakes, have the purpose in which the lakes, because Bangalore is full of lakes earlier, and now it's been taken over by the concrete, this thing. Nevertheless, impact of rainwater harvesting in our own plant, greenery in our own house. So as a movement, we should start our own area as far all the industries are concerned. A lot of industries are there today. Many of our members are there. So let us take green plantation as a major theme to enabler for getting the water back into our system. So it's important for us. At the same time, let's go into our basic things in terms of the design, in terms of design of the process. I think we as a new generation to take care, we have to take care for the next generation. I think we should understand it's an important, not that only we use water, we should not even waste water. Get back into the recycling of the water. So it's an important topic. And TERI, we have worked very closely with very many activities in TVS Motor also. In TVS Motor, we recycle 100% of our water. We're trying to save I think last year we had given back water 212% back into this thing. Is it possible? We have something like 12 to 14 lakes inside our thing, getting into the rainwater harvesting. So it's all a mindset. So we, as all the engineers today, take oath to say that we are going to protect our environment. We are going to have greenery in our area. We are going to work towards implementation of all the processes which will ensure conservation of sustainable areas in our work and ensure that the children are very good today. The children in schools are even trained that they should have more and more of greenery. I think we as industrialists should take an oath today and let's get back the greenery and get back the earlier days of good water requirement and recycling. It's the most important thing for us to go to the next level 3 of GDP, level 5 of GDP. That growth will come, and Indian culture we should be able to practice very well. And on behalf of BCIC, we have got 850 members growing strong today, and we have a BCIC office in Japan. They're also very keen to work with us for small scale industries in all the quality areas and improvement areas. Recently, this month, we signed a virtual office in Netherlands and in Saudi Arabia too. And Vietnam is very keen to work with us. Italy is keen to work with us. So we are growing in a big way, and we have something like more than 250 programs. We have 28 expert committees. So almost every day there is a seminar in our Bangalore Chamber of Commerce. We want to take Namma Karnataka, the gateway for future India, as a real theme to take it forward. And once again, I thank Mohan, Rajesh, Jha for this initiative on a very, very important day and a very, very important topic. And again, once again, thank Akash Deep and Ravitej and look forward for learning more. And all of us, you're welcome. We can share what we've done in TVS Motor, what Bosch and what Toyota have done. We will share more and we'll try to bring this culture of proactiveness in our entire design of processes and design for the environment and sustainability. Thank you very much and looking forward for learning in this meeting. Thank you very much, Mohan and Rajesh, and thank you,
Thank
Akash
you.
and Ravitej. Thank you.
Thank you, sir. Thank you, sir. Okay, so without taking much of the time of our participants, also I'll quickly move to the overall agenda of this particular awareness session. In fact, so I think we all are aware this is a part of our ESG webinar series. Of course, this is the third one, mainly on the occasion of the World Water Day, what we have today. And I think the climate resilient water management, when we say, of course, we know that lots of course, issues we are seeing and how the climate resilient the water management system should be. In fact, who can be the best one to say on that is, of course, from the TERI and, of course, one of the other member what we have from Paryaavarneer Engineering, in fact. So I'll just introduce the speakers. So we have speakers from TERI, Mr. Akash Deep. He is a B.Arch from, of course, and the M.Arch in Sustainable Urban Designing and Creative Urban Practices, in fact, from Glasgow University. And he's currently working as a senior program manager in GRIHA from almost more than a decade, in fact. And of course, he is heading multiple in fact, the areas in GRIHA, and of course, having the experience of more than 1,000 projects, in fact, in India. So you can imagine the experience he's going to share today, from his side, in fact, right? And of course, he's having multiple national, international, in fact, the publications also in the field of sustainability and the water. Right. So, and another speaker we have, of course, Mr. Ravitej Hegde. He's BTech and MTech in environmental engineering with more than 12 to 13 years of experience in water treatment, water overall, the liquid, zero liquid discharge and other areas of the sustainability. And of course, he is currently a CEO, the Chief Executive Officer of Paryaavarneer Engineer and Consultant Private Limited. And of course, he's leading a team of the passionate environmental engineers can, of course, bring the more climate resilient, the water management maybe through, in fact, the more best practice in recycling through the best treatment system. And of course, he's having a experience in multiple corporates, in fact, in his past. So I think with this, I'll just I'll start the overall kind of presentation, maybe through Mr. Akash Deep, in fact, who would be, of course, touching upon the overall some of the, in fact, the kind of practices that we need to adopt, not only in a corporate world, but in a personal way, also in personal manner, what all things we can adopt and how it's going to bring a climate resilient water management overall. And of course, Mr. Ravitej would be taking us through the water management system through the treatment and recycling part, in fact, right? So with this, I'll hand over the platform to Akash ji. And of course, I request our participants also to put your queries in the chat box, which will be taken up at the end of the session. Thank you very much. Over to you, Akash ji.
Thank you, Rajesh, and thank you to the Bangalore Chambers of Commerce. It is a pleasure connecting today with all of you, and a very important day itself, Water Day. And interestingly, being in GRIHA and TERI, water is one of the challenge which we see is the next decade challenge to the whole world, basically, which we are about to face. On that note, I'll just share the presentation. Just let me know once screen is visible. Yes, I hope the screen is visible.
Yes, please.
Yeah, thank you. So what we'll do is I'll just briefly introduce about what we are and who we do, and Rajesh has already done that. And then jump on to water, 2 or 3 slides, and then jump on to water for the whole process, basically. So you're aware how this data and the examples which we are going to see in today's presentation, from where they are coming, basically. So just to brief you, as I work as a senior program manager with GRIHA Council. Now, GRIHA what people know as GRIHA is the rating tool developed by our country, and it's the national rating tool of our country, green building rating tool, which is adopted by Ministry of New and Renewable Energy in 2007. This was launched by TERI, and TERI being one of the oldest climate NGO working on the climate front with both nationally and internationally, and has been a think tank advising the government of India and also the UN at many fronts in terms of policy intervention and framework requirements across the globe for climate resilience, basically. So in 2007, Ministry adopted us as the national rating system, post which we got multiple recognitions across the globe. And most recently and most important one happened in terms of the, as I was also mentioning, that the Paris Agreement and the commitment which India has given at the global level for the 2070 goal of net zero. So GRIHA has been recognized in these commitments and the government documents in terms of whatever carbon mitigation activities which we'll be doing in our country in built environment. GRIHA is the Indian tool to measure this mitigation in the built environment for carbon reduction, whether it's energy saving, whether it's carbon saving,
Hello?
whether it's, sorry, yeah.
Hello,
Hello.
Rajesh. Yeah.
I think say you're on mute, unmuted.
Yeah.
No, somebody was speaking at the background. Yeah, please.
Yeah.
Sure.
Please mute your mics, please.
Yeah.
Please
So
go ahead.
Thank you. So what happens is whatever we are doing individually as a person, as a project, as a house across India, one of the important thing is to note that in sustainability, the numbers which we are doing, the carbon emission savings, energy savings, water savings, all has to go to the government database. Now, through this database, what helps government is to make sure that they get funding, they show at the global platform what and where we are. And as a force, India is a force to reckon with, basically. And that these numbers in the built environment is provided by GRIHA Council to the government of India every year, basically. It goes in the INDCs, is good in the biennial report every year, which is submitted for the COP Paris Agreement status report. To help you out, there are multiple ratings in both small scale, large scale. To make it very easy, it's very simple. Doesn't matter what you're making. You check the scale, you check the type, new and existing, and you take the rating. So water has always been a crucial part in front of other ratings variants which we have. This is the most recent one which we have launched in terms of carbon emission reduction. That's called the DHP program. And water positivity is one of the areas which has a major part in this whole decarbonizing habitat program. So the water positive certification, which is being done, and multiple industries are part of the certification, is also a way in which they can help measure their innovation or strategies which they have adopted on site. And that measurements help them claim their ESG, help them do the ESG reporting and claim their benefits out of that, basically. So water has been a crucial part in sustainability as such, as I was mentioning. This is one of the other certifications at the base level, the bottom of the pyramid, our affordable segment. This we do with banks. And again, in this also, the energy, water, and carbon are the three major areas which we look for them. And on these basis, we help make the bottom of the pyramid much more efficient, basically. And it's both ways approach. So bottoms up and top down approach. Coming to water now. Water everywhere and no water to drink. That has been an past saying, which is now coming more and more true in the recent times. And no better place to tell this than Bangalore, because Bangalore has been known for, as I was mentioning, as a lake city of our country, and somehow now it is the dry, because it is moving towards a dry city of our country in generally. And one of the reasons is that globally, as we all know, we have lots of water which we see, the ocean, the water bodies, the glaciers, lakes, cities across the globe. But only 1% is actually potable and usable. And that's where the challenge lies. The consumption of water has increased drastically because of increase of population, the activities, the industrialization. But the production of water is not there. It's more that what you have done is that 1% as a percentage of that has also been contaminated and used, pushed towards not usable, basically. This is the reality, and this is the past reality. This has become worse now. This is this was 2007, I think so, in which, as per the WHO, every 6 person, 1 person was not getting water, and now this is for every 6 person, 3 persons are not getting potable water or access of potable clean drinking water, basically. Issues, and in India, it's very, very, very straightforward. We like everything in its harsh realities, so nothing is balance in general. So we have too little in some of the countries, some of the states and cities. We have too much at the same places probably, and some other new locations. We have too dirty. The water which we have is becoming too dirty to utilize again. And lastly, everything revolves around too many. So that's our country's the biggest challenge. Everything in extremes. Too much, too little, too dirty, and too many. I think so. Everything starts from too many, and that's where our current problem starts in terms of water. But also one of the challenge, and as I was mentioning, that Bangalore is one of the cases where we already know that we are on the stress levels, and not just Bangalore, but in that ways, India as a whole. As per the reports by government and the international bodies, we are pushing towards water scarcity level. We are already crossed the water stress levels, and that's not just India, that's there across the globe. We are already in the water stress levels, and by 2050, we are bound to reach the scarcity levels, basically, if nothing has been done. But for every challenge, for every problem which we face, there is still a ray of hope for us, especially in India. The location of India in the world map is very crucial in terms of water. We have been blessed with one of the purest form of water which can be utilized if utilized properly. That's the rains which we have, the monsoon rains, which caters to most of our water consumptions across the subcontinent throughout the year, reviving our groundwater systems, reviving our rivers, perennial, the non-monsoon and monsoon rivers. But again, somehow we end up cutting our own base when we have some solutions with us. This is one of the most I'll say unutilized and misutilized resource in our country, mismanaged resource in our country. And very good example of this is India has a very diverse landscape in terms of topography. So you have the hilly regions and the top Himalayas, the Western Ghats, all these hilly regions are there. Then you have the plateaus and the Ganges region and all the valleys where you have lots of water and agricultural land. And then you have the coastal belt, which is there. But interestingly, we have built such cities and some parts of desert as well. We have built such cities across all topographies which are easily flooded. Doesn't matter where you are. And for example, I think so last year we had floods in Jammu. Jammu is a hilly region in a mid of a hillscape, basically, where water is already in a scarce level because water does not stay because of the slopes of the regions. But we have managed to flood that city in the midst of the hills, basically. Similarly, if we Rishikesh is another example. Gurgaon is a very classic example of copy pasting from the western regions without understanding the urban complexities of copy pasting. Floods comes first and rains comes afterwards, basically, on a rhetorical region. Even if in a small drizzle, the Gurgaon and the Delhi region gets flooded because of the ill designing of the cities which we have done. Misconceptions in terms of water management, rainwater management. Jodhpur, Jaisalmer, desert region was flooded last year, last 2 years consecutively, they had floods, basically. Central valleys always had been an issue with the Yamuna and Ganga overflowing in Uttar Pradesh, Maharashtra, Madhya Pradesh, Bihar regions. Mumbai, every year we listen into the news, we have floods during rains because of the coastal region. Kerala, Chennai, Odisha, and Chennai, a very interesting example again. One of the city in 3 months it had Chennai, we all know, hopefully Chennai was the first city to be out of potable water in 2021. And in the same year, it had floods after the 3 months, basically. So there's something wrong which we are doing in terms of so-called development approach. Interestingly, as Sir was also mentioning, India has a very rich, enriching culture, and in which we had strong ties with our nature, and we used to worship all our elements. Basically, we used to worship water, we used to worship trees, we used to worship animals, which we used to worship sun. That was what we used to worship, basically. And because of that culture, we used to make sure that we were preservative, which we were always, I'll use a bad word, but we were stingy in utilizing resources. And Indians are famous across the globe for being stingy, but that's what is required to be sustainable. Always use what you need, not what you want, basically. And one of the major principle of sustainability is to be stingy in utilizing resources, basically. Whether you don't like the word stingy or not, that doesn't matter. But that's the challenge of our current times. We are too many with too less resource left. If we do not become stingy, there will be no resource left at the end of the day. So that's the rainwater mismanagement in our country. One of the best resource which we have, but one of the worst management of the resource which we have done in our country. Droughts, floods, very common in our country. Same location, same city. 3 months you have droughts, 3 months you have flood. That's the current irony of challenge which we have in our country. Also, the water which we have, most of it is being polluted with various consumption patterns across the cities, rural, urban areas. And interestingly, this is the water which is recycled and sent to all our flats, and all our wastes also go into the same water. Whatever type of treatment happens at the city level, that's what you get from this water. And then we also put our, so it's, as I was mentioning, the water cycle, very important. What you give back to the water, it is what we'll get back from the water at the end of the day. And one of the challenges which our cities are facing nowadays is the potable water, both surface water and underground, is being contaminated so drastically that it's actually the potable water availability has reduced drastically, and that's why pushing our cities to stress levels, basically. But still there is hope. As I said, we can still improve. We can still adopt to our and we can learn from our previous culture, previous behavior patterns. 3 basic areas where we can work. So the first one being the design of the system, because what happens is design is the key to being sustainable at low cost and no cost. Once you have built a building, it's very hard to change. Design, give time, give it more time to think through, come up with solutions, come up with local solutions which are best suited for your problem. One of the challenge in our other challenge which we face in our current times is we have ample amount of information. I'll not say knowledge, we have ample amount of information because of the global connectivity, the networking, the internet and everything. What lacks is choosing the right knowledge out of that information, basically. And that's why the designing is very important of any system, any project, any technology, because that is a low cost option. You can do what all alternatives, you can do innovations in that phase, and it's no cost to you. But once it is built and you jump into the operation maintenance system, there's only limited way of becoming sustainable. And the best part of in this scenario, what India has is 60 to 70% of the build form is yet to be built of a country. If we make that 60 to 70% right, we still have a huge hope for a country to be sustainable, actually speaking. And lastly, again, the user behavior. This is one area which has no cost to it, but it saves a lot if we change our lifestyle. And changing our lifestyle in actually adopting the older lifestyle is what I'll say, because we were sustainable past. Just remove the so-called development phase from our country, the 50 years while the Britishers left and before the Britishers were here, we were sustainable, not just in water utilization, everything. We used to have food which was local, which was as per the climate. We used to have buildings which were local, which was as per the climate. We used to have clothes which were local as per the climate. Now we are developed. That's the irony of development. So in general, as a resource in a built environment, it's important that we reduce our demands and then look for supply side management. So in generally in a building, you use water in your landscaping, in your building water demands, so your consumptions, your HVAC and construction. So whatever way is possible in design, in systems, first we reduce our demands. Whatever reduced demands we have, then we go into the supply side. How better my supply can be, whether it's recycled wastewater, whether it's rainwater storage, or better it's recycling and recharging rainwater, basically. So it's demand and supply. If you jump to the supply side directly, automatically it will be unsustainable because you have large demands. Large demands means I need large supplies. Automatically, when I'm going for large supplies, sustainable sources will not be possible. So reduce demands, step-by-step process, then go for supply management. If we go into the building demand requirements, it's very straightforward, very simple. One is how to change your user behavior. And these were taught the good habits. I think so still it's there in the children's book, the preschool books and all. Close the tap while brushing. Please do not take showers. Use bucket for bathing. I doubt we still follow those basically. But in general, other than habits, what you can change is your systems. Very straightforward, use efficient system. Nowadays, we have this option of low flow fixtures, pressure valves, reducing devices, sensors, which make sure that your water consumption is reduced. But again, as I said, all of this is very good as a technology, but with technology comes lots of maintenance. And with technology, it is important to understand the technology to fullest before using it. And a very interesting example and story behind the low flow fixtures, which happened actually. So we all know these low flow fixtures work in terms of it reduce the water supply, but because of the pressure, you still are able to wash your hands, take a shower, or WC flushing because of the pressurized system. But what happens is this systems work only one in terms of your good pressure, 3.1 bar pressure, or the there has to be a maintained pressure for these systems to work basically. Now, in most of the I say small scale houses, individual houses, which we have, or G+1 or G+2 stories, most of us still have gravity fed system in our homes or buildings, and gravity fed system has its limitation in terms of increased pressure, which you can achieve in a 3 or 4 stories building basically. Now, because of our copy pasting habit and the new building specification or the BOQ which we create, and I'm open if somebody wants to correct me if I'm saying something wrong. What we do is copy pasting. So all taps have to be low flow fixtures. Doesn't matter where they are, what they are, and how they are used. Why this copy pasting is a challenge? For example, all flats wherever we are living. I think so in your bathroom, you have 2 taps, right? One, you have a shower on the top, and then you have a tap at the bottom. Now, if you go into the details of generally, we all take shower. I doubt anybody is still using the bucket and mugs at their houses. But that lower tap of your shower, below the shower, any guesses what is it is used for your in your house? The tap beneath the shower, what is it used for? And I'm just come out of the presentation and go into the chat window. If anybody wants to mention why, for what use do you use the tap in your bathroom underneath the shower? It's very basic, nothing probably, or your maid would be using it for filling buckets, for cleaning the floor and everything. Now, interestingly, for filling a bucket, you do not require a low flow fixture. Bathing, no shower use. Yeah, that's obviously no shower use. If you are using a bucket, that's very good. But if you are filling a bucket, you do not require a low flow fixture because it's a 10-liter bucket. You'll fill it anyways. Doesn't matter. It's a low flow fixture or a high flow fixtures. Now, what has happened is because of that is you put a low flow fixture in that tap. At the end of the day, it's one flat has 2 or 3 bathrooms. So you have 3 taps which are low flow, which will not work because at the end of the day, I need it for bucket filling. So I'll open that aerator and keep it aside and use that bucket filling process. Now, in one flat, 3 taps. In one floor, 4 flats. So 4 into 3, 12 taps. And in a building of G+10 into 10. So 120 taps have been installed waste of resource, because at the end of the day, that resource will not be utilized. But because of what we have done is a copy pasting of specification. We want all taps low flow fixtures. Doesn't make sense. Even that tap aerator is a resource. It has been manufactured with some energy, with process, with material, and then being utilized. At the end of the day, you are, what you are doing is taking it out and not using it because it is not usable, because practically it is not usable. So copy pasting of systems has to stop if you have to become sustainable. And this is a very interesting example in that scenario. So low flow fixtures is one which we are all utilizing in our offices, homes, and other industries. Then comes to landscaping. Again, a very interesting challenge. As I was saying, nowadays, no, we don't have landscaping at all in our cities, and that's one of the biggest challenge which we have. But whatever landscape we have to make sure we minimize the lawn. We use native species and we use irrigation systems. Now, a very interesting question for you, and please use chat again. Anybody know where did the lawn come from? Lawn, grass, it came? No? Yes, the carpet grass. Where did it came from? Where did the carpet grass came from? It's not Indian. It is not Indian. Indian, UK, US, UK is the answer which I'm looking for. So Britishers, when they were here, they had these green carpet lawns in their country. When they were here, they wanted to see that carpet lawns. And we say na, they have left and Britishers telling English. I'll be using these Hindi faces. They have very interesting tone to it somehow. I'm sorry if somebody is not understanding the English Hindi muhavres, but very interesting to use these cultural phrases. So they're gone and they left their carpets to be watered. We don't have water for drinking, but we are pouring water on their carpets and still maintaining it. Indian local grass is doop. Doop does not require that much of water. It's a very local grass, but we are somehow want that carpet grass look in our offices, which is not local to us. It's almost takes more than 5 times the water of a normal grass or the Indian native species, but still that's what we want. Same ways, can you tell me which is one of the species of trees which you see very regularly across most of our cities, but it is mostly non-usable. It has no use at all. And it is there because of us architects. And I'm an architect, that's why I'm saying because of us architects, I'll say that. Not because of the client, but because of us. Any species you have seen which has no use, but has been seen across our city landscapes. Which you can take whichever city you want. And whichever site you want. I'll say your site as well. One of the maximum tree which you plant in your site. I'll ask you that simple question. And that is a palm tree, basically. Whichever city you go, whether it's palms. Now, interestingly, the palm requires a lot of water, has no shade, and once the area where palm is growing, you cannot grow any other species in that area, basically. And we do this with the architectural presentations which we do with the students and faculty, basically. Now, what happens is when we are showing a 3D to the client, which is you in most of the cases, we always show, because we have to show you the elevations, we always have these palm placed in my elevation so that my elevation is visible to you as a client, and you also appreciate that because my building is looking jazzy and all those things. And at the end of the day, what you want is, okay, this is the elevation 3D. I want this to be visible from all sides, interestingly. Because there is palm in the architectural 3D, it's palm everywhere. And we forget to mention that to the clients, because what happens is if I put a neem tree, one, my elevation is not visible. Second, my neem tree has so many leaves, my computer will fail rendering it because computer requires each leaf and each line to render. It will take ages to render that 3D for me. And that's why palm, no leaves, just a pine and just a trunk and easy to render, visible elevation, good for showcasing, but not for implementation. Sorry to say that. And that's where the miscommunication happens. Small miscommunication, not much. It's so these are some areas where actually it's very important to look back what we have had in our ancestral architecture, ancestral designing, ancestral knowledge. A very good, easy question for you all again. When if you want to go to a picnic, and nowadays picnic happens in a mall or I don't know where, but yes, let's go 50 years back or 10 years, 20 years back, and then ask this question. If you want to go to a picnic, where do you want to go? Generally, where did you want to go? कहाँ भेजते थे? Everybody was asked to go to probably. Answer, please. Where do you go for a picnic? Sustainability is that simple. It's very basic and very logical. Anyone? कोई picnic नहीं जाता था? That's very interesting. We are all bookworms inside our houses. Parks, yes, very good. We were forced to go to parks near rivers, Konkan area. Yes, वो आप holidays में चले गए. I'm just asking one our picnic option which our friends and family used to have. Now, interestingly, when we go to parks, why were we pushed to go to parks? And this was very interestingly put by Sir also in the beginning. Why we need parks in our spaces? So I'm just reiterating that fact, and with some factual numbers, probably you'll be able to understand why parks are needed. Why do we go to parks basically? Why were we asked to go to parks, or why did we go to parks to do picnics? It was green, lots of oxygen. The wind was still cooler over there than the city area, the parking areas, and we can play throughout the day without sweating much because of the trees and the green. So now a very interesting question again, and it's good if you can be interactive. That will be very interesting on the numbers basically. The park becomes cooler because of the perspiration. So through photosynthesis, tree perspire, the air comes and make the space very cooler. Similarly, as us, we perspire in hot, and when the wind blows, we become cooler. Any guess how much our body perspire in a day? If I put you in the sun outside for the whole day, any guess? Hot and very 42 degrees Celsius outside, and if I hang you on a boat, sorry for using that, and put a bucket beneath you, how much water will your body perspire if you are alive? Any guesses? You can unmute yourself also. That's fine if you want to unmute it and say something. If you're tired, writing it in the chat box. Come on, give me a number. How much perspiration do you have in a day? अगर मैं आपको बाहर रख दूं 1 liter, half a liter, 2 a liter, probably. No replies. 300 ml. Oh, that's very less. Anyone wants to increase the bidding? It's a bidding process. 300 sold, 3 to 4 liters. Okay. 3 to 4, 1, 3 to 4, 2. No sold? No. So generally, depending on the metabolic rates of each body, but in general, if I place you in a hot, dry sun outside without a shade, a body perspires around 8 to 10 liters a day. Now, imagine, just look outside your window if you have a window per se, and choose a fully grown tree from outside, a neem tree or a peepal tree or a 10 or 15 years old tree. Now, can you tell me a number? How much does a fully grown tree perspires in a day? Imagine your surface area and so many trees, so many leaves and a tree. Just imagine, pick a number. How much does a fully grown tree perspires in sun, which is it's always there outside on a dry sunny day, 42 degrees Celsius? Again, give me a number. 100 liters. Anybody wants to increase the number? Or we sell it 100 liters? No. So interesting number coming to you. A fully grown tree. Yes, species will vary and a climate will vary, but a fully grown tree in general perspires 5,000 liters a day. And that's where our problems come. You are removing 5,000 liters from the climate per day when you are cutting a fully grown tree. And that's why the challenge with carbon emissions, heat waves, everything starts from there basically. And to give you perspective of that problem, here is what it's called. I think so you have all felt this, but this is what it's called, the urban heat island effect, that our cities have become hotter because of non-availability of trees. And this is not we are just pushing through all cities. This is what is actually the example. So this is Gurgaon, and interestingly, we play a game with our kids. Spot a tree. Oh my God, that's वो जो spot a difference वाला होता था, तो we play a spot a tree in this map, and that's Gurgaon. That's Pritampura, Delhi region. That's again Ambedkar Nagar. So that's what we have done to our cities. And interesting, that's Bangalore. And these are all 2009 maps. I'm sure if you open it today, you'll be, again, this game becomes much more difficult for you if you open the Google map today, basically, of any of our cities. And interestingly, we are talking about carbon emission reduction. We are talking about green sustainability and all, but logically, the oxygen which we use in our earth, basically for breathing and for living, we all produce carbon dioxide. We have created instruments such as cars, such as industries to produce carbon dioxide. But the only thing which can produce oxygen is plant. Carbon emissions increase because of what we have increased: population increase, machine increase, carbon increase. But the only thing which can give you oxygen, we are reducing that day by day. And that's what Sir was emphasizing. Let's bring gardens, let's bring sparks back to our life, basically. A very interesting example from any of our cities which we can take, not just Bangalore. It's the same across even tier 2, tier 3 cities now, because they are aping the Western so-called modernization planning, and more spaces for cars, less spaces for trees and people to walk around. So this is the biggest challenge which we are facing in our cities designing and city planning nowadays. But still, there is possibility if somebody is looking for it. There are landscaping designing in which you have not hard pavings, but soft pavings, which allows the water to go in, which allows the space to still be cooler and still not have lots of grass. Parking areas which can have covered, which can have grass pavers, so that still some part of water goes down. Shading the hard paved areas where possible. And providing so now, interestingly, we all are industry specialists, and we all have gone for approvals for our building plans multiple times. Now, interestingly, if you see the planning nowadays, what you have is 8 to 6 meters of road. Then you have the building footprint of the campus, which is majorly above a basement, and that 6 meter wide road which you have left is a fire tender access, which is a mandate requirement. Now, interestingly, if you see the lifespan of a building which you are creating, it's basically 60 to 80 years. Now, can you imagine in that time frame, 60 to 80 years, how many times will a fire tender come on your site? I'll say none, or probably once or twice if there's a mishap. And because of that once or twice instance, what we are creating is that 100% of hard paved surface, and basement is anyways there. So everything is a hard paved surface, basically. So what projects have done, I think so, Indira Bhavan, one of the ministry building, that's a government building, which I'm giving you an example of. What they've done is everything is grass pavers there is a grass street pavers around the building, and that's 100% fire tender access is green. And they've stopped creating design in which you have a car and taking it around the building. Merry-go-round, I want my car to reach my flat. If it is for us, I'll do a planning in which I can take my car into my flat itself. I don't want to get down off my car and walk a distance. But what they have done is, okay, this is my building campus. Car comes in, goes into the basement directly, comes out and goes out of the site directly. There's a whole, the fire tender access road is created, which is whole green patch. There's now hard paving in that site, basically. And whatever pedestrian, so it is used for pedestrian pathways and everything, basically, and green area. So there are solutions, there are possibilities if we are open to it, basically. A very interesting incidents happened in the social media, which we saw one of the developers. Actually, what happened was, so there was a video from US or UK, I presume, in which road was being painted high SRI with high SRI paints to increase the heat island effect, so that white colors reflect the heat and it does not absorb the heat and increase the heat in the city area. So in that video, what you see is two patches which was barren in the so there's a road and two patches which was barren, basically. And then there was this painting going on by one of the video. So one of the developer commented this technology which we are bringing to our campuses in our country, and innovative technology coming to India. Now, what one of the other person commented was, this is a good technology, very nice, very good. You're investing and you're spending money on it, but there's a free of cost technology which is available to do this work, and which was just plant trees along it. It does not require any money. It is easy to manage. It gives you multiple benefits. Instead of then first spend too much of money, first high technology, and then look for solutions which are low cost and no cost, basically. So it is sustainability is not costly. Sustainability is very local. Sustainability is very basic. Sustainability is common sense. Just copy pasting any systems does not work, basically. Some case studies of landscaping. So instead of having these carpet grasses or lots of lawn, this is what happens. So if you have 100% lawn, there's no saving. But the moment you reduce your lawns and increase your shrubs and trees in that in the same landscaping area, you receive huge amount of water savings. And if most of you must have visited some of the Western countries, and you have seen that even in the common areas in the city landscape, they do not use grass nowadays. Everything is shrubs, because shrubs is easy to maintain. It has more retention property of waters. Trees, yes, trees and shrubs. That's what they have gone for. Maximizing your shrub area. That's what we were discussing. So this is Rajasthan, again, Jaipur, Manipal University. What they've done, only minimal patches of grass, and mostly it's all shrubs, basically. And whatever now they have started planting the trees to shade the hard-paved areas from their sites as well. Grouping of trees is very important. So you put a palm and a people tree. People tree will never go, because palm will take all the water which people tree requires, basically. So grouping of trees in landscaping becomes very important. Where you are planting what species becomes very important. So that knowledge is essential when you're doing your landscaping design. Xeriscaping is a very interesting art which has been there in our dry regions, and now most of the cities are running towards dry regions, so they will be required to adopt dry landscaping, which is what it is. But it has its own pros and cons. It can be implemented. There are irrigation system efficiencies, irrigation systems which can be implemented to reduce your water demand in landscaping, because landscaping is one of the huge water demands in our countries. Drip irrigations. This is one of the, so what even in our flats, individual flats, if you have a terrace garden or a balcony garden, you have lots of pots. You just put a 2-liter Coca-Cola bottle, cut it, put holes, put water. It will automatically have watering for next 2 or 3 days. You don't have to go and put water again and again, basically. And this is one of the water audits and certification we did in one of the sites. What we found was the water which was coming and reaching STP, there was a gap of around 40% water. Somehow it was just going somewhere. And interestingly, when the whole audit and certification process happened, what we realized that 40% water was actually being utilized for pots, because the owner or the company was having good interest in plantation. So they have lots of plantation on pots. And that is one area which is not measured or monitored. And that's where the water was being lost and not accounted for, basically. So various ways of reducing water consumption in landscaping. On roof, so majorly shrubs or native trees. And interestingly, what we have always been taught, water has healing properties, not just in terms of consumptions, but in terms of its sound when it's flowing, its visualization when the water is flowing. And many of the times, if you go and search on Google, on YouTube, on music apps, what you'll find, the relaxing music or relaxing is the sound of nature. That's what it is at the end of the day. And that nature, one of the key element is water. Now, interestingly, in all our designs, what we do, this is very interesting example in which it is made important that water flow is visible to eyes, basically. And in our design, what we do is take a pipe, that's PVC pipe, and take all the water out of sight, out of problem, out of mind. But that doesn't happen, basically. It creates much more bigger problem. So open drains, obviously, it requires maintenance. It will require maintenance. But that's what the soothing effects of water is. You listen to the water flowing, even the rains which you are having, the lake water bodies which you used to have in Bangalore. Those had not just the climate effect, but also healing effect on our minds. providing basins, swales, which is it is called. So in dry season, it is something like this. In winter seasons, in rainy season, all these swales are connected, and it's again a Bangalore project, if I remember correctly. This is Sabic Bangalore, if I say. So all these swales which you see, these are interconnected. These pipes get connected to this. So this pipe is connected to the next swales in the site. And what happens is each of these water bodies, so-called small water bodies, help in the local microclimate. Also make sure that the recharging of water happens significantly, because nowadays nothing is possible because of the planning which we do: basement, road, end of site, basement, road, end of site. That's what the consecutive planning which we follow in our city is. So majorly doing rainwater harvesting at the individual levels, planning this and this process. A very interesting example from Hareda, Panchkula. Just give me a second. Sorry, water. Can't live without it also. Yeah. So very interesting example for from Panchkula, Haryana. Now, interestingly, it has an interesting architecture design as well. But especially why this example I'm picking today is we are majorly dependent on air conditioning systems in our country. And but interestingly, Bangalore used to have a climate where logically air conditioning was not required, but because of copy pasting of glass buildings across from the Western civilizations and Western so-called development buildings, we have pushed our buildings towards air conditioning dependent buildings. One of the good thing about this building is, one, you can see the glass, but you may think that this is an air conditioned building, but this is a 100% non-AC building. What they have done, and this is running for last 10 years now in the Panchkula region. This is hot and dry climate. So again, do not copy paste the design. It will not work in your region, Bangalore, because both the climates are very different. It's a good suited design for hot and dry climate. Now, if you remember, and if you have interacted with any of the North Indians, there was, I'd say there was, because nowadays it is very oftenly not used in most of the buildings or the houses. We used to use these desert coolers in most of the buildings, houses, which is basically a big fan with three sides jali, and the water is sprinkled on those jali. The air which comes in actually then is cool because of the water on the side jali. So this building has been created as a big desert cooler. How is that? Now, if you see the glass and the boxes, these are called solar chimneys, and this is the southern facade generally. So if you see the south facade, this is the south facade. Generally, if you ask anybody which facade the glass should be, it is always on the northern facade, because northern facade glass does not get incident high sun. But this is specifically requires high sun because of the desert cooler design. So what they've done is this is the glass facade on the south, and then you see the boxes. These are called the solar chimneys. What it does is this heats this office space very rapidly in the day because of the so much of glass and concrete chimneys which have been created. Then what they've done is these solar chimneys inside the room, it has ventilators inside the room at the top, basically. So everything hot, so basic of physics, everything hot rises, so that hot air escapes from these chimneys outside and creates a negative pressure in that office space. Now what they have done is they have created this courtyard in the center of the building. And what they do interestingly in this courtyard is something called literally sprinkling of water, which is called misting technology. So what they've done is they have this misting technology in which water is sprinkled inside this courtyard. If it's too hot in the day, so 2 times a day, morning and evening, before this office begins, and afternoon after the lunch hours. But if it's a little bit musty, humidity in the air, it is done once in the day. And in rainy season, it is not run at all, basically. What it does is it creates a positive pressure and a cold air inside this courtyard. So logically, as per physics, positive pressure, positive to negative air should blow. But we have these corridor walls, which we create in our design. But what they have done is in this corridor walls at the bottom, they have designer jali. So if I see the section of this room, so they have this designer jali at the bottom left, and then they have the vents on the top left or right. So there's an automatic draft which is created in the room, and that is what the building is cooled for. basically. There's no air conditioning and anything in this space. A very interesting example for from Maharashtra. They Govardhan Eco Village. They have it's a green campus which they have developed. It's an ESCON campus. Do go and visit with your family. It has mud blocks, stabilized blocks. There's no AC. There's just fan. And in summers also you'll require a blanket. I'm sure of it. And we required it. Everything is on the site, from the site, for the site. Food is grown over there. It is what is used for eating. All the waste which is generated, biogas, and manure is created for that. It's outskirts of Mumbai. Yeah, do go and visit if you want to understand what sustainable lifestyle living is basically. From modern day times, a case study from down Pune again. So this society had generally this is a normal society which has 5 to 8 Ks per flat per month maintenance cost, and currently they have reduced the cost to 3 to 5K, and they have a target of 2030 to reduce it to 0. How they are doing it? They are installed the solar PV from themselves. Solar hot water was given by developers. Very interesting data management system. I'm not seeing this even in corporate offices. They have individual flat energy water consumption patterns, and they display it in the reception lobbies, highlighting it with red and green, who are using over excess water and energy and less energy and water basically. This is the first site which I've seen in which RWE has come forth and actually stored runoff and reused it on their site from their own design perspective. Reusing RO water, changing aerators, and one of the site in which water flat meters were installed by most of the flat owners. So PPT presentation. Very interesting example. And now coming to the close of the presentation, last but not the least, net positive certification के बारे में थोड़ा सा. So net positive is in generally we give more back to the nature than what we are consuming, and that's what the basic water cycle is. Now, interestingly, in water positivity across the India, rainwater system is one area where people claim that they are net water positive. They have given back more than what they are using. But in GRIHA, what happens is every number which you claim has to be measured and monitored. And that's why if you're claiming that you are recharging so much of water, it has to be metered and monitored. If you are using some water, you have to meter and monitor, because that's what net positive says. Numbers needs to be validated. Without validation, it has no value at all. And interestingly, there are multiple projects which have gone ahead, and one of the companies which we are working closely is ABB and DS groups and hotel industries and all across the country, with which we are helping them. The TERI team audits them, then we have them certify and make sure that they are net positive in terms of water through strategy. So what it has is, it has two parts, quantitative and qualitative. Quantitative is demand versus supply, direct numbers. Qualitative is how better water systems can be improved. Water quality, water metering, smart mini grids, O&M protocols, because interestingly, water systems do not have O&M protocols. If you have and proper policies are there, it's very good. It can be further upgraded basically. CSR activities and water positive index above 1.5. So generally, the audit process is you have register, you audit, report for with recommendations. Recommendation to be implemented. Option 2 is already implemented. If it is implemented, proceed for certification. There's a scale in which you are certified. So from 0.3 to 0.94 is towards water neutral. Then water neutral is 0.95 to 1. Net water positive is 1 to 1.5, and above 1.5 is super water positive, in which you are giving much more than what you are using basically. Process is very as simple: demand reduction, supply management, rainwater management, and recycle and reuse. Some of the projects which we are doing. So two of the Bangalore projects which we have done, both are from ABB, which is ABB Neil Bangla and ABB Pina, both are water positive. And one of the examples from Pina only, I will give it. So they had this interesting old water body within the campus, and one of the redesigning factors was that this was being converted into a modern rainwater harvesting system. So interestingly, the audit report says, don't do that. It's a very good system. Preserve it. It's an old system. And we did that. So they have hotels, offices, lots of shrubs, lots of trees, metering, sewage treatment plants, rainwater bodies. So natural bodies helps you make sure that the water is recharged properly. And on that note, I'll close. I think so. I overshot. I don't know.
No, thank you, Akash. In fact, it was quite insightful, and of course, we understood like lots of initiatives. Of course, a company or any, in fact, individual houses also where we can adopt and have a overall management on the water in a more efficient way, and of course, somewhere, of course, it's gonna make our approach more sustainable. So now, with that, like, of course, we'll have a Q&A at the end of the session because we are having a certain, of course, the time limitation over here. And I'll quickly move to our next speaker, to Mr. Ravitej Hegde, in fact, who would be sharing with us the kind of the water management when, of course, it has to be treated, and of course, how it can be further be recycled. And of course, he'll also share his experience at how they have been supporting, in fact, companies to do so. Yeah. So thank you, and over to you, Raviji. Thank you.
Yes, thank you so much, Rajesh sir, for the opportunity. We thank BCIC for giving us this opportunity. So I believe my slide is visible to you. Can you confirm?
Yes,
Rajesh, sir?
please. We can see, please.
Yeah, thank you so much. I'll just directly get into the subject. To start with, so I'll be covering 6 points to be specific. Initially, we'll talk about my organization in a bit. I mean, we'll take small amount of time. Post that, I'll be talking about why this water resources is vulnerable and what is the impact of climate change on this very issue of water scarcity. And then we'll talk about how, as an industry, we need to address this issue in terms of water management. And following that, I'll be discussing about the water dependency reduction and how do we have to reduce the emissions from the treatment plant operations. Finally, I'll be touching upon how do we have to extend this initiatives to the supply chain. So to start with, I belong to an organization called Paryaavarneer Engineers and Consultants. We are an environmental engineering firm, consulting firm. We are into various kind of environmental services. On a daily basis, we treat more than, from our operations, we treat more than 12,000 meter cube of water and wastewater, more than 70,000 meter cube of water. We have established various water and wastewater treatment projects. We have over 10 people of environmental engineers. We have a workforce of over 140 people and incredible client list of over 50 clients, and we provide various kind of environmental services, starting with water and wastewater treatment solutions, legal compliance management, sustainability and climate change advisory, and other services. So this few of our clientele, and we have been awarded with various awards for our startup product called IoTreat, which is basically an IoT-based unmanned operation of treatment plant solution. So we have been listed by the by the central government as well for our initiatives, and the product called IoTreat, which is one of the startup product which provides the unmanned operation of treatment plants. So coming directly to the topic of today's discussion. So why are we talking about what is the connection between the water resources and the climate change? So basically, if you see the studies across the globe and the IPCC reports, it indicates that the rainfall is going to increase in certain areas because of the climate change, and in certain low areas the drought cases will be increased. So if you interestingly, in the region of Karnataka, by the climate change, the rainfall intensity is going to increase. So that, however, by considering that, it doesn't mean that we are going to have plenty of resources or water available for us in the future. So this is an interesting study done by EMPRI, so which indicates that which districts of Karnataka are highly vulnerable because of the climate change in terms of their water availability and the availability of water for their intended use. So interestingly, the Bangalore and the surrounding areas are highly vulnerable to the climate impact on the water resource front. So water becomes, becoming water efficient is not only essential I mean, it is not because of an sustainability or because of the greenwashing initiative, but it is an essential and it is a risk that the industry is facing, and it is essential to be addressed in order to ensure the sustainability of the business today, especially in Bangalore and in the surrounding areas from where most of the attendees today are attending. So with this context, I would like to understand, I mean, I would like to get into the strategies that the industries are getting into or can get into to address the issue of climate, resiliency in terms of water management. So before I get into the discussion, so I would like to clarify on the aspect of what is climate resilience. So basically, so it is the action that we need to take in order to cope up with the changes that the climate change is going to bring up. So the climate change is inevitable at the business as usual scenario, and if that happens, how has to cope up with the water management, or how do they have to cope up with that business even when the climate change is a reality or it is going to happen. So considering that, there are four major strategies that the industries, we need to adopt. So first thing is we have to reduce the dependency on the fresh water, because the water availability, as we had discussed, as we have seen in the previous slide where we were discussing about the scarcity of the water, and at today's date, in the Bangalore and in the surrounding areas, we are facing this issue of the water scarcity. So the dependency on the fresh water reduction is a necessity. So we do have to reduce the water dependency. Second thing is we have to reduce the emissions that occurs in the operation of these treatment plants. And third thing is it is not only sufficient to reduce the water dependency in our fence, but it is essential to extend the scope entirely to the supply chain, because there is something called embedded water or water footprint for each of the products. Just like the carbon footprint, there is the terminology called water footprint, which indicates what is the embedded water in a product from its cradle to the grave, cradle to the grave. So if you come, recently in the Aayog has released a guideline on the water neutrality, where it is mentioned, it is essential for the industries to go across their supply chain to become the water neutral in terms of that guideline. So hence the industries who are opting or who are aiming for the net neutrality or water positive, it is very essential to extend their actions to the entire supply chain rather than limiting that only to the fence. And there is a lot of scope for most of the industries to intervene in the society in terms of lake regeneration or water conservation projects in the society, which can also impact which can also help the organizations to improve their sustainability scores. So now we have understood that these are the four strategies that the industries has to take up. So let us address one by one on what exactly the industries can do in terms of addressing each of these strategies. So the first thing that we have discussed is the reducing the water dependency. This is a cliché word, and everybody has heard about the reduce, reuse, recycle. It is it is a word. These are the words which are very vaguely used everywhere, and it is the word that everybody knows. However, how do we have to implement that in an industrial context is something that I wanted to discuss today. So the reduce is something where we need to there is the strategy by which we reduce the freshwater consumption or water consumption at the usage points. There are two major strategies that the industries can adopt. One is the administrative measures, and the second one is the technical measures. When it comes to the administrative measures, water management requires a robust daily management, because it is a function. Every industry works in a cross-functional manner, and there are a lot of functions who contribute to the consumption of the water. So it requires a lot of hierarchical monitoring and measurement of water consumption at various points, as well as water discharges at various points, to ensure that the water consumption is actually reduced at the points. The second aspect, I mean, the administrative control doesn't only limit to the daily management, but it also requires the regular audits by the cross-functional teams, if possible. And there are awareness sessions that you need to conduct for the people, for the whole workforce, which can enhance the awareness and sensitization across the workforce, which will reduce the domestic water consumption as well as in the process water consumption. And the second aspect that we are going to talk about is the technical measures. When it comes to the technical measures, there are a lot of technical solutions available at point to reduce the water consumption. There are the smaller solutions like the aerators to the taps, which are also technical interventions to the air-cooled cooling towers, or there are a lot of the treatment technologies which are available, which can reduce the water consumption, fresh water consumption in the industries. When it comes to the reuse, everybody is aware of the rainwater harvesting. So there are a lot of very good examples, as you have just seen the example of ABB India in the previous session. I mean, previous speaker session. So there are a lot of industries who have effectively harvested the rainwater, and they are using the rainwater for most part of the months of the year. So rainwater harvesting is a very good tool, because Bangalore as an area receives over 600 centimeters of rainfall every year. And if we are effectively utilizing this rainwater, then it can effectively replace the fresh water that we are drawing from the other sources. Also, there is a necessity to reduce the evaporation of the rainwater, which has been harvested. So there are a lot of solutions which are available to ensure that the evaporation is also reduced. There are chemicals which are available which will hinder the evaporations. There are the structural measures where you can store the water in the closed tanks. These are all the measures that you can take to reduce the rainwater evaporation. The second aspect that can be looked into in terms of reuse is the cascaded use of water. So if we come to any industry, the industry requires water at various application points. And all these application points doesn't require the same quality of water. I mean, if we consider, for example, a steel industry has various qualities of water requirement. There are requirements for the quality which will be having a TDS of less than 50 for the boilers and for the various applications. And there are applications which requires the TDS, these are total dissolved solids of below 200 milligram per liter for the applications where the water gets into the contact with the product directly. And there are applications where the water is used for the dust suppression, that is used for the indirect cooling towers. So there are various qualities where water which is of not very good quality can also be used. So if if the industry uses the same water for all the applications, then it is the waste of the entire resources. I would like to bring one more point here. The water management water reduction is not only about how well you manage the water. So the skill is how well you manage the solids in the water. So if we manage the solids in the water in the right manner, the water consumption can be reduced. So I mean, it requires a lot of elaborations on this, I understand. But if we, for example, if we are utilizing the water discharged from a cooling tower, which will be having a higher dissolved solids of around 600 to 1000 total dissolved solids, that can be effectively used for the horticulture purpose or even for the dust suppression purpose, because the horticulture requirements for the horticulture purpose requires the TDS of less than 2100 milligram per liter. So there are various application points which requires different qualities of water which can be used. So there are this industry specific strategies to be developed to make sure that the right quality of water is given to the right application. So this is the very key aspect of the reuse of water. Third aspect is recycle, that everybody understand that it is also a requirement to treat the wastewater before you utilize or when you discharge it outside, wherever it is applicable. So the wastewater treatment requires different technologies or different plants to be installed at the place. And the second aspect is whenever there is not enough water, recycled water available, you can also opt to buy the wastewater from the other sources, treated wastewater from the other sources. I would touch upon an important aspect in terms of recycle. So the recycle is not only about having the best technology at place. Many of the places we visit, many industries where they have opted for the membrane bioreactor sewage treatment plant, and followed by and the plants which have various technologies ranging from UF to RO, and they are utilizing the treated water in the horticulture and flushing purpose. Basically, the if we are using only for the horticulture and the flushing purpose, the treatment, the quality which is required is not does not require an UF or RO to be installed at the place. So it is very important to choose the right technology for the right application. So the selection of the technology should be based on the intended use of that water rather than having the best at all the places. And as I was mentioning, it requires, even though we have all the infrastructure available at the locations, it requires a lot of close monitoring and the audits at a regular intervals. And it is a legal requirement at current date because of the CGWA or KGWA to have the water audits, and it is also because of the various voluntary recognitions also ask for whether the organizations conduct the audits on the water consumptions or water use or not. So the water audit is not only about going and checking for the leakages at various places or checking the only checking at the points where the water is getting leaked. So it is about a holistic water audit should cover three aspects. The first thing is assessment water use efficiency. So secondary initial mapping of where exactly the water is getting used and what is the technical best water quantity that should be consumed at those points. And the second aspect is about the water efficiency management system. So it is not only about establishing a system or establishing all the infrastructure and leaving it to the operators to run the entire activities. It requires, just like in ISO 14001, which is also incorporates the water management. So you should have an effective water management system which should run through run a PDCA cycle across every 365 days in a year. So it should go through the PDCA cycle. The target should be set at different levels in the organizations. The activities plan has to be developed, the activities to be conducted, audits to be conducted, and the management should review the activities, and a system-based approach has to be established. So whenever the water audit is conducted, it should also analyze what is the management system which is established and how robust is the management system. And the third part is about assessment of engineering and infrastructural adequacy. This is the major part of it, where we need to assess what is the engineering gaps and opportunities which are available and what are the gaps in the supply system. So all these things have to be incorporated, or all these things has to be audited when it comes to the water audit. And we understand, I mean, most of the things that I am talking now is something which is very generic for most of the industries, and many industries understand all these points. And there are various challenges that everybody knows in spite of having all the infrastructures, in spite of having the best management system, there are still various challenges that the industries are facing. The first and foremost is lack of application points for the treated wastewater. We come across a lot of industries which produce, say, 100 kV of treated wastewater every day, but they don't have any application points where they can utilize that treated sewage or treated effluent back into the process, because they have hardly 30 kV of requirement for the flushing or the horticulture purpose. The rest of the treated wastewater, which is of a properly good quality, cannot be utilized because there is no usage points at all in the in the cases. So we suggest to go ahead with the update the facilities to give the very good quality, so that the quality of the water meets the raw water quality. And there are options which are available nowadays. There are a lot of avenues which are there to sell the treated wastewater, so that can be utilized. There are challenges with respect to the inadequate treated wastewater quality. This can be addressed majorly by addressing the infrastructural gaps, if there are any. And the first and foremost thing is improvise the operations and automate the entire treatment plant to make sure that the quality is adequate for the reuse applications. And there are various cases where the treated water quality is good at some point of time and it is not good at some point of time. And this variations in the treated quality makes the industries hesitate to use the treated sewage or treated wastewater into the process back. So this can be addressed through the standardization of treatment operations and the automation of treatment plants. And higher operational cost is one more concern because of many of the MSMEs, many of the smaller organizations or smaller industries which are in the supply chain of even the major automobile or the textile industries, face the challenges that the operational costs are so high that it becomes very infeasible for them to operate the treatment plant, putting all the manpower to operate the treatment plants, putting all the chemicals, putting all the infrastructure to run the treatment plants. But as it is a cost of the compliance that has to be complied, so the automation and the right treatment technologies can solve the problems. And finally, the perceptual challenges to use the treated wastewater by the workforce. This is one more challenges that the industries are facing, because if we give the wastewater, or especially the domestic wastewater, treated wastewater back into the process, or back into the domestic users, there is a perceptual challenges that the industries are facing. In fact, at the current stage, it is even possible to treat the wastewater to the extent that it can be used for the drinking purpose. We all know the case studies of the new water in the Singapore, where it is being used even currently for the drinking purpose. So it can be technically used for the drinking purpose as well, but it requires a lot of awareness building among the workforce to make sure that the perceptual challenges are addressed. So I'll move on to the second aspect, because I'll have to rush in terms of time a bit, but I'll rush to the next agenda point, which is about reducing the emissions from the operation of treatment plants. So we all might think that treatment of wastewater treatment plants doesn't require much of does not emit or does not contribute much to the emission of the CO2 as when it comes to the entire organizations. But even then, as we can see, this because the literatures and our experiences indicate that the power consumption is responsible for 68% of the overall CO2 emissions in a typical sewage treatment plants. So if you consider a 100 KLD sewage treatment plant, it will emit up to 60 tons of carbon dioxide annually. And each and every STP will consume between 1 to 2.5 kilowatt hours of electricity per cubic meter of wastewater treatment. So this indicates that it is very essential to address the GHG emissions even from the wastewater treatment operations, which is majorly contributed by the power consumption. So this can effectively, if we drill down further in the aerobic treatment plant systems, it is the air blowers which contributes to the 70% of the overall electricity consumption, because air blowers are usually of higher kilowatt rating motors, and they'll be running around the clock in an aerobic system, which will result in over 70% of overall electricity consumption will occur from the blow operation. So it is very essential to optimize the blower operations in a treatment plant to make sure that the overall CO2 emission is reduced by the operation of the treatment plants, which can be effectively done with the utilization of variable frequency drives, because we don't require the same amount of oxygen to be supplied air to be supplied in the aerobic system all the amount of time. So there are various options which are available, which can be utilized to make sure that the overall electricity consumption in the STP operation or in the ETP operation can be reduced at least by 20%. And it is very interesting that if you reduce the RPM of the motor even by 10%, the power consumption will be reduced 27%. So it is very effective in terms of power consumption reduction when you utilize the variable frequency drives. The last point that I would like to come to is about the footprint reduction. As I was discussing, it is not sufficient to reduce the overall water consumption within the boundaries. So it is very essential that we need to extend even especially in cases of the companies which run through the larger supply chain or larger supplier base. It is very essential to run the entire activities across the supply chain to have the larger impact. So this can be done with the 4-pillar strategy of capacity building, where a specific guidelines and the project repositories can be developed and can be communicated to the supply chain companies, especially to the MSME companies who doesn't have the resources as much as the larger organizations have. Conducting capacity building programs for the suppliers can be taken up, and handholding on the ground. So you can help the organizations can help their supply chain partners to implement these activities that the industries are doing in their premises, and can help in monitoring and assessment, can conduct the can help in setting the targets and roadmaps in the supply chain, and the mother companies can help the supply chain partners in regular audits and assessment. Finally, they can also provide the awards and recognize the supply chain partners in reducing the overall water footprint. So that's it. I think this is about the overall ways or overall strategies that the industries can adopt in terms of addressing their water footprint and addressing the risk of water shortage that is not going to come, that has already come. So it is a risk that is already at the door of our industries. So it is the time that all of us has to work towards addressing these issues collectively. And it is not as a this is not something that I'm telling as a consultant or an industry service provider, as the responsible citizens of Bangalore, especially which is facing the unprecedented water shortage, or it is going to face a lot of challenges in the months to come. It is our and my moral responsibility to request all of you to take up certain activities and help the organizations in the supply chain who are not so resourceful in terms of addressing these issues. Thank you so much. And I really thank the opportunity given to me by the BCIC. Thank you. Over to you, Rajesh.
Yeah, so thank you. In fact, Mr. Akash and Mr. Ravitej, lots of topics were there to be discussed. The time is very short. It's very difficult. Topic is such that we whole day, in fact, we can talk on, because really we have to address this challenge. Of course, we climate resilient water management. Of course, lots of topics we discussed. I think without wasting much of our time, or I'll I know we have crossed the time.
Just to continue on this, I am a veteran of more than 30 years in this field, but today it was a good learning on many aspects. Both Akash and Ravitej spoke very well. And this is coming out of their experience. It is not that they are trying to speak something which is already available in some documents and literature. And especially I like this idea of copy paste. In Bosch, we say always copy paste, because you need not have to reinvent the wheel. But we have to be careful, on whether the terms and conditions remain the same, whether the environment is the same. So based on that, we need to copy paste. Sometimes we try to copy paste good practices from our locations in Europe, which we may have to slightly modify for Indian conditions. And it was also, many things can be done at one's individual level in their homes, in the apartments, and this is the future I look at. We need to go to the level of net positive. We have seen many countries doing this. The best example is Israel, which has very less, fresh water, but they are one of the best managed water resource, in the entire, I would say, in the entire group of countries. Also, Ravitej, even though he's a consultant, I think from his consultant background, he has hands-on experience on various aspects. Also this cascade use of water, it is very much apt. Sometimes we try to put the treated water for one use, but depending on what is the end use, we can, reduce the cost of treatment and use it for different purposes. I'm sure the participants, we had close to around 40 participants. It was good learning for them. And also you can directly get in touch with this two gentlemen who have a lot of resources. Also, you can write to BCIC. And thanks, Rajesh, for your excellent coordination for this, this call. And Rajesh, you can close with your closing remarks. Rajesh, you are on mute. So I think he has some network issues. Thank you once again. Thanks all. And hopefully it will rain shortly, because Bangalore usually gets pre-monsoon rains in the months of March, April and May. Otherwise, the issue is going to be very serious. So as Ravitej rightly said, each one of us has responsibility to reduce our water consumption so that others can use that. So thank you very much and have a nice day. Bye-bye.
Thank you, sir.